Some algebraic fractions. Now, I did make a video on solving a lot of these, so past paper examples, etc. I should put a link, I don't know, somewhere, so you can see these, but just kind of as an explanation of what we do. They look extremely intimidating when you see them, but if you understand what you should do, then you're going to kind of simplify that and make it a lot easier for yourself. And whenever you see this, I'd say the biggest thing that you can't do is because there are multiple terms at the top and the bottom, we can't just go, oh, I'm going to scratch these out, these reduce to 0, and there we have. Because this is going to count 3 marks, and I can promise you that will not give you 3 marks. Okay, so this is definitely not what we want to do. Whenever we have fractions, we can only reduce things or cancel them out if we have one term at the top and one term at the bottom. And I think the problem comes in when we kind of first learn about, let's say, reducing things to 1 or cancelling out, let's say 4x squared y. We get examples like this and we say, okay, well, 2 goes in itself 1 and 4, that's fine. There's an x at the top and 2 at the bottom, so this one's going to cancel out and that's going to cancel out, and I'm left with y is 2x. But what we don't realize when we study this, this was one term. 2xy is one term, and 4x, well, squared y, whatever is one term. Whereas in this case, we have 2 terms because there's a minus and a plus in between these terms. So it's whenever we see fractions with these terms, we have to be very, very careful because we can only reduce once we have one term at the top and one term at the bottom. So how do we get one term? Well, we need to factorize. So it looks extremely bad, but let's just take a look. I kind of ignore the bottom first, and I just look at the top and I say, well, can I factorize that? There are 2 terms. Is there anything common? Yeah, there's an x to the power of 3 common, actually. And here is an, oh, sorry, yes, this would be a 1 because x to the power of 3 times 1 is going to give me that term, and then the plus x. So here, if I multiply these 2 things, if I distribute this, then I'm going to get that. Okay, so now I've done the top, very simple. And now I ignore the top, I've done it, and I just look at the bottom and I say, okay, well, that's a trinomial. There's nothing common in all of them, so I'd probably get here with 2. And here, I'd have to say, like with algebraic fractions, they're always going to be able to factorize because that's what they're testing. I haven't seen them do something here that you can't factorize and then you have to do the quadratic formula or something. This usually works out. And I can tell you now one of these brackets are going to be 1 plus x or x plus 1 or something. But let's just see how it goes. So trinomial, I have an x in the front and x in the bottom. And here, well, in both brackets, and a 1, the only factors here would be 1 and 1, and this would be x plus 1 and x plus 1. Now it looks like the 1 plus x and the x plus 1 aren't the same, but 1 plus 2 and 2 plus 1 is the same thing. So when I get to this, I have a whole bracket here that can reduce to 1 or cancel out with a whole other bracket, and I'm left with x to the power of 3, x plus 1. Again, we cannot cancel this x and that x because this is 2 terms. Yeah, so we just kind of keep this as our answer. Let's look at the next one. This is a favorite one to ask, is they have the difference of squares at the top and the trinomial at the bottom. So this is a difference of squares, so I'm just going to do the top part first, ignore the bottom, and say, well, it's going to be x. Well, difference of squares always has the square root of this number and the square root of that number, and then I just make sure the signs are different. And now I look at the bottom. Again, this is a trinomial. There's going to be x in the front and x in the back, or at the not front and front. And now I just have to think either 1 and 15 or 3 and 5 would get me to 2, and I think 3 and 5 would get me to 2. And again, the giveaway is kind of that there's a 5 here, so it's probably going to be one of them as a 5. But I wouldn't play guesswork, but it kind of usually works out like this. Now we just have to figure out which one is the negative and which is the positive. So the bigger number here is the plus. So plus 5 minus 3 would give me plus 2. And here I can see that I have one term at the top and one term at the bottom. And I can just cancel those out. And I'm left with x minus 5 over x minus 3. And you'd want to cancel those things out, but Don't do it. Don't do it. Just keep it like this. Why? Write in the comments below why we can't cancel that out. Or if you don't want to, it's fine. I'm going to give you the answer now. You cannot cancel out when there are more than one terms. Okay, let's do one more example. One more example, and then you can move on to the video where I have all the past paper questions, and you can go through those. Try and do them actually by yourselves first, and it's better to kind of run into those mistakes. So let's do one. 2x squared minus x minus 3 over 2x squared. No, I don't think this is correct. 2x plus 1. Let me just check. Sorry for the delay. Let me just check. Did I write this one down? It looks a little bit worse than it should be. And I don't want it to not be able to cancel out. Yeah, no, I was correct. I think this should not have... Sorry, guys. Really sorry. It shouldn't have the 2 there. Okay. Cool. So at the top, I know this is a weird one because we have a x squared with a coefficient that has not, well, doesn't have a 1. So we're going to have to do that little trick where I know I'm going to end off with 2 brackets, but just on the side here, I'm going to take the 2 and the 3 and I'm going to multiply, and that's going to give me a 6. And then I have to get to negative 1x. So with 2 and 3, I can do that. And it's going to be negative 3 plus 2. So I'm just kind of doing this on the side here to make my life a little bit easier. Just want to check if I have space. Yep, I would have. So the 2x squared, I'm going to do plus 2x minus 3x minus 3, because these two things will have to give me that negative x, which it does. And then I can factor out a 2x here. 2x, and I'm left with x plus 1. And there I can factor out a negative 3, I think that would work, and I'd be left with x plus 1. Why is that a plus? Because negative 3 times plus 1 would give me negative 3. If I made this a negative as well, then if I multiply negative 3 times negative 1, I'd get a plus 3, and that wouldn't work. And luckily for me, I got some brackets that are in common, and then this would be 2x minus 3. Okay. So it's kind of a side thing, and now I'm just going to write this in here, x plus 1. Oh, could have written this a little bit better. X plus 1 and then 2x minus 3. So a bit of a more tricky one because I had to do it on the side here because of that factor, or the coefficient not being 1. And here it's pretty simple. I would have an x and an x, and that's a 1. So I can only have a 1, and that's going to be a plus. And you see how nicely this works out? I have one term at the top, one term at the bottom, and I have this big factor that's the same. And I'm left with 2x minus 3 over x plus 1. And I can't do anything further. This is my answer. Really happy. There you go.